All right. Well, Sunday was fun. It's okay though. All right, I do want everyone looking up here. This is stuff we did last week. Exterior angles. Okay. We learned that the outside angle equals the sum of the remote interior angles. Okay. So here we go. Outside angle equals the sum of the remote interior. So we're going to write first this outside angle, then equals, we're not going to do that, then equals the remote interiors added together. Okay, so outside is 120 equals, and what am I adding together here? Three x minus 2 plus the other one, x plus 14. Okay, so again, outside equals the sum of the remote interior. Now you could end solve it here to get the answer. We're going to solve it all the way. Okay, I need everyone's heads up, please. Ms. Marshall, can you help us get our head up? Okay, we want to combine like terms on the right side. So we got an x and an x. That's 3x and 1x. You want to add them together. 3x plus 1x is what? 4x, right? Let's write that down. And then our constant numbers, we have a minus 2 and a plus 14, or a negative 2 plus 14. What does that give us? 12, good. Don't forget that minus sign, it makes it like a negative, and that's very good. So bring down 120. Now it's a two-step problem, x is on the right. So we are going to solve for x. We get rid of our loner 12 by subtracting 12 on both sides. 108 equals 4x. And then your last step to get rid of that 4, what do we do? Divide by 4. 108 divided by 4 is 27. Okay. And you could plug it back in to get these other angles. Yes. All right. So what we're going to do now is, first of all, last week we took a quiz on Friday, so I'm about to finish it up. So if you look at me over here on this slidey board, okay, these are two things from last week that you want to make sure you put there. Angle side and isosceles theorem assignment and the exterior angle assignment. Those two are due already. Make sure you try to get it as soon as you can if you haven't already. They're not in Skyward yet, but they will. Okay. Today we're moving on to medians and centroid. And we're going to be noticing some out. Oh, no, not that one. Okay, right here. So, medians and centroids. Okay. Now, I'm going to be honest with you. This can be a little complicated. If you pay attention closely, you'll get it. It'll be all right. Okay. So make sure everyone's following along. Okay. Okay, medians and centroids. What is a median? First of all, well, there's a picture right there, and let's read what it says. It says a median of a triangle is a segment, okay, whose endpoints are a vertex. Go ahead and underline that word, vertex. I'm going to go red, actually, here. Vertex of a triangle and the, underline this, midpoint of the opposite side. If you look at this picture over here, C is your vertex and letter D is your midpoint. Now, how do I know the letter D is the midpoint? What else do you see next to it? These tick marks. Okay? So I know it looks like it's in the middle, but you need these tick marks to kind of tell you, hey, those are equal halves. If it's equal on each side, that's for sure the midpoint. Okay? So is everyone with me? We have a vertex, we have a midpoint. If you connect it, that is a median. Okay? So median from a corner vertex to a midpoint on the other side. Now, here's the deal. You can make 3 medians, line, 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 and they're all going to cross at what's called a point of concurrency. It's a fancy new word, concurrency, right? There sometimes, rarely, when you're driving, you'll get to a place where there's like 3 roads crossing at the same place. I'm pretty sure there's a, in Castle Hills, not too, I mean, we're in Castle Hills, I think, but it's Lock Hill, Selma, Northwest Military, and some other road. They all actually, let's see if we can find it on Google Maps. Give you a little picture here. Lock Hill, Selma, and Northwest Military. Well, I'm wrong. Well, dang. Okay, well, I thought this was, see how these 2 roads cross right here? I cannot draw on this, but if there was a 3rd street going through the same place, that would be a point of concurrency. But hey, even these 2 streets cross at this little red dot right here. Okay, so my example was foiled. But back to the note. Sorry. Okay, so all 3 medians cross at the same point called a point of concurrency. Okay, and that is the center of a triangle. So the 3 medians cross at a point of concurrency called the, underline this, centroid. Okay, that's a new vocab word. Think of centroid as one of the centers of a triangle. And that's kind of weird. That's one of the centers. So there are multiple centers of a triangle. Okay, technically there's this centroid. There's also an incenter. There's also a orthocenter and a circumcenter. Okay, 4 different centers of a triangle. But this centroid, it says, is always inside the triangle. And this is very important. We're going to do a little thing on this tomorrow, but go ahead and underline this. It's the center of gravity because it is the point where the triangle will balance, okay? So right now, if you cut out a triangle, and if we found the centroid, you could balance that triangle on your pencil point, okay? That's how you balance a triangle, at the centroid. Cool. So you make 3 medians from vertex to midpoint, vertex to midpoint, vertex to midpoint. They all cross at the centroid. Now, this is where it gets complicated. I need everyone locked in. Looking over here. Very important. If your head's down, you need your head up. Please. Very important. So let's read this. The centroid of a triangle is located 2/3 of the distance. So go ahead and maybe box that, 2/3 from vertex to midpoint. Okay, so you need to write small. I'm going to zoom in, okay? So does everyone see that P in the middle is the point of concurrency where the 3 medians cross? That is called the what? Starts with the C? Centroid, right? Okay, so what I'm going to do is I'm going to label this fraction stuff that we just got. Can you go back? There you go. Okay, so it says it's, goodness gracious, 2/3 of the way. So everybody, between A, the vertex, and P, the centroid, go ahead and put 2/3. You're going to have to write small. 2/3. Okay, that bigger section is 2/3 of the way. Now think about this. from P to Y, the smaller section, if the big section is 2 over 3, what's the other section going to have to be? No. So think about it. There's 3/3. If 2/3 are gone, what's left? 1/3. Okay. So if you have 2/3 for AP, I want you to write a little 1/3 for PY. Okay. Now that's the basics of the notes today, but the application can be complicated. So everyone's with me. Big section's 2/3, small section's 1/3, and then there's the whole thing. We're also going to label this, okay? So whenever we're doing these, I want you to think of 3 things. There's a big section, there's a small section, and then there's the whole thing. Big, small, whole. So let's go ahead and label this. 2/3, go ahead and put big on top of it. That's the big section. 1/3, go ahead and put above that, that's the small section. Try to write this more legible here. And then from A to Y, everybody look, from A to Y, that's the whole median. Go ahead and put a little bracket. The whole thing is right here, okay? All the way across. Now here's why we're labeling that. Is there a way to just lock this thing down? We're gonna write some notes, okay? There's a relationship between all 3 of these things. We're gonna write them down right now. And then we're gonna see how it works on number 1 and 2. So let's go ahead and write this down. Here we go, everyone's with me. All right, so go ahead and write big equals 2/3 whole. Everyone's writing this down? Everyone, writing this down, right? Please. The big one, if you're looking for the big part and you have the whole thing, you do the big equals 2/3 of the whole. Similarly, the small is 1/3 of the whole. That's kind of what we already wrote down. If you know the whole thing, you can figure out the other 2 by using 2/3 for the big, 1/3 for the small, okay? Now, here's where it gets dicier. If you're given the smaller or the bigger one, working backwards to get the whole thing can be a little bit more complicated, okay? Or going between big and small. So let's start with that, okay? If I'm looking for the big one and I have the small one, it's going to be the small one times 2. Here's why that works. Isn't 2/3 twice as big as 1/3, right? 2 is twice as big as 1, right? So if you have the small section, you can get the big section just by multiplying it by 2. And backwards, if you have the big one, to get the small one, you just divide the big one by 2. And then once you have a big and a small, the whole thing is just big plus small, obviously. That's the segment addition postulate. Okay, so these are just some things that can help you, and I'll show you how they work on number 1 and 2. Okay, but first I want you to write down those little notes. So do you see the application is a little bit complicated, and the only thing we know is just 2/3, 1/3, but there's multiple applications here. Again, please write small, okay, because this can be a lot. So we're going to start off with the first thing that they label, which is AF, okay? So from A to F is 9. So please make a big bracket. From A to F is 9, okay? Now skip the GE part we're going to skip down to find what? Find AG. A to G. Now you tell me. From A to G, is that the big, the small, or the whole thing? The big one. Everyone see that? AG is longer than GF, right? It's not the whole thing, but it's the big one, okay? So I'm looking for the big, and I have the whole thing is 9. So let's look at our little notes. If I'm looking for the big thing and I know the whole thing is 9, I'm going to use this very first thing I wrote. Big equals 2/3 of the whole. Okay? This part is 2/3 of the whole thing 9. So let's go write this down. Okay, so big equals 2/3 of the whole. And the whole thing we said is 9, so 2/3 times 9. Do y'all know how to do 2/3 times 9 in your calculator? If you do or you don't, let me show you how. If you hit Control Divide, it'll give you a fraction bar. 2 on top, 3 on the bottom, go to the right, times 9. 2/3 times 9 is 6. Does everyone know how to do fractions in the calculator? Control, divide, fraction. Okay, so I ended up getting 6. So that means AG, my big section, is 6. Cool. So if you're given the whole thing, multiply by 2/3 to get the big one. Multiply by 1/3 to get the small one. Okay. All right. Let's do another one. I'll do it in another color. Go green. Okay. Now the next part, it says GE is 2.4. So everybody kind of write small here. Go ahead and put 2.4 between G and E. And this time we're looking for CE. What's going on here? CE, okay. Now, look at CE. Is C all the way to E the small part, the big part of the whole thing? The whole thing, right? So CE is the whole thing. So now I got to think backwards. From the small one to the whole thing. Well, to get the whole thing, I need the big part, small plus big, right? So before I can find the whole thing, I need to find the big part. So I want you to look at this top one right here. Does everyone see how I wrote at the top on the right-hand side? Big, the missing part, is the small one times 2. Okay? So let's first find GC, the big part, and it's going to be the small part times 2. So let's go ahead and write that. Big equals small times 2. Okay, which is 2.4 times 2. What's 2.4 times 2? 4.8. So you can label that for GC and just remember, that's not the final answer, that's only the big part. We want to find the whole thing. We're going to take the small part and the big part and add it together to get the whole thing, right? So let's do that. The whole equals small plus big. So that means CE, the whole thing, equals 2.4 plus 4.8. The small plus the big, which equals what? 2.4 plus 4.8 is 7.2. Okay. So again, if you know a small one, double it to get the big one, add them together to get the whole thing. Okay, I know that's a little complicated, but it's doable. On the next one, let's go back to red. Okay, let's label what we know. All right, so it says, I've got to get out of that. What's going on here? Why? Oh well. So it says ZW is 7. Go ahead and label from Z to W, 7. Now you tell me, is that the small, the big, or the whole thing? Does everyone see ZW is the smaller one, ZK is the bigger one, WK is the whole thing? So this is kind of like number 1. From W to Z, we're going to do, and we're looking for KW. KW is the whole thing. So we're going to go from small to the whole thing, just like we did in green on number 1. So first, let's find the big one. So we can then use that to find the whole thing. So the big equals the small times 2. The small one we just said is 7, so 7 times 2. What's 7 times? Bless you, what's 7 times 2? So ZK, the bigger one, is 14. We know the small one is 7. So again, to get the whole thing, we do small plus big. And we get 7 plus 14, which is 21. Okay. And then last one on this page. So LX is 8.1. From L all the way to X is 8.1. Is that the small, the big, or the whole thing? From L to X. Is that big, small, or the whole thing? Whole thing, right? All the way across. So let's go ahead and use that to figure out LZ. LZ is the big section. So kind of like the first one we did on number 1, the big is 2/3 of the whole. And we know LZ, sorry, we don't know LZ, we're looking for LZ, but we know the whole thing is 8.1, 2/3 times 8.1. Again, you can use your calculator. 2 control divide 3, go to the right, times 8.1. And we get 5.4 for LZ. Okay. I know these are complicated. I know this is like, what's going on here? But if you remember, if you're given the whole thing, multiply by 2/3 for the big, multiply by 1/3 for the small. If you're given the small part, just double it to get the big part, and then add them up for the whole thing. If you're given the big part, divide it by 2 to get the small one, add them up to get the whole thing. Okay? There are multiple different types of problems you could have when you're doing these. If you flip over your notes, we're not going to get into it with coordinates or expressions yet. So what I'm going to do is I'm going to let you think on this. I'm going to give you an assignment that you can start today that we're going to work on tomorrow. So no rush, but I want you to try to start it today. Keep these notes, okay? I'm going to pass out the assignment now.